Uh, hi all. Welcome to ThinkStack. So this is a basically design series that we are starting today, and the other series that we are already running related to the coding interviews. So in short, we have a design series and another is a coding series, right? So that will continue. Both will run in parallel. So today we'll discuss more about the design series, right? Okay. So now think about it like the way basically let's say you are running one startup. Okay. Okay, just giving one example, right? How you should think about a design problem, right? So now what you do, first buy a domain, right? That is your first step. Then what do, you host your website using a single server and put this domain behind this server, right? Correct. So now think about it. This is like a basically I would say any startup, right, which goes through this phase, right, which is like you have one server and you have hosted your website and just you have purchased the domain and you have mapped that domain to that server, right? So whenever someone accesses, so let's say you have bought a domain startup.com. So then whatever your xyz server will be there. So when you will hit, so this server will be like whatever is API will be get called will be forwarded to the server, and the server will then send the response and that will be shown to the website, right? That is a normal flow, right? And this is a simple single server approach which at this early stage of the startup you do it, right? Now think about it like you are selling some products. Now what you do is the hire a influencer. What you do is you hire one influencer. What you wanna do is with that influencer is basically you wanna promote your product because you wanna build the presence, right? Social you are doing a social marketing in short. You wanna build a presence on the social media platform in short, right? So you hire an influencer. Suddenly you start getting more traction on your website, right? So whatever your startup.com was the website, so that will start getting some traffic. So for better name, let's say a.com is your startup, right? So a.com will start getting more traffic, right? Because you are an influencer, and that influencer, because of that influencer marketing, I would say you'll start getting some traction. So some users will start coming to your website, right? So it will be more than the what usually used to come because there was no any marketing earlier, right? So let's say once you do this, right? So like more and more people start accessing your website. So let's say that server that you have configured, right? So that has a some X capacity. But what happens is when let's say that X capacity is it can support 100 users, but due to the hiring influencer that led to the traction on the website, and post influencer marketing now started seeing 10k users. Okay, so 10k users, this was like a think about it. At a peak you were seeing like 100 users coming on your website. Now it has increased to 10k users. So what happens, the server capacity is same but your users has increased. So basically the load on the server goes up post influencer marketing. That is a simple thing. So if we draw, right, so this is your user, think about it, this is one block, then you have a server sorry, yeah. So post basically 10k users, your server will start feeling key load, right? Now what do you do? So when you see this, this is like a common problem you see, right? Because earlier you were thinking like basically you're starting, right? It's like a very early stage of a startup. Now post influencer marketing you started seeing some traction now, right? So to understand this, right, like how the one after another, right, what sort of challenges you face, right? So we'll try to cover 4 to 5 concepts in this. So the listing down the concept first. Concept. So which are the core concept, I would say, for a system design? So one is basically single server architecture. Okay. Another concept is basically your scaling challenges. Third concept is you have your vertical versus horizontal scaling. Fourth concept is load balancer. And fifth is a caching. So I will explain like from a website which you started for a startup. So how once you start like doing some marketing and you start getting more user to your website, how these core concept will be used, right, one after another. So that's where I'm starting. So think about it. You're selling some product, right? And there basically what you did is it's you have the user, you had the server, and you had the database. These were the mainly high level component you had, right, when you started your startup. So every user request for your product, either selling a books or any other product, it first goes to the server, and then user sends API request that goes to the server, then looks for the data, right? You like whatever is required in the API call, searching in the database. In the database, what it does, database returns the result, and then same result you forward from server to the client. So it goes back like this, right? Now what happens is basically this is where like you are searching, like user searches it and that goes to the database, and this is simple thing, right? Now think about a case where user searches some word, like let's say talk about a product. Let's say you are selling some books, right? So I'm talking about a book name, like let's say, or a better would be some books, ABC books, or I'm searching about a Harry Potter book, like, okay. So now that keyword goes to the server and server searches in the database, right? That's how the flow is currently, right? But what happens is, because currently the traffic is low, so server is able to handle the request, and database is also at the same time able to handle the request, starting with the 100 user, now move to the 10k user for the same. Okay, so now what you see is you start seeing the more queries for the, let's say, searches are going to the server, so it will start taking more load, it start taking, right? So basically you start seeing a performance degradation at the same time, right? So what you do in that case, so this is where like your business is growing, okay, but now what you have to see is your traffic has increased, right, because of business is growing. Now you have to see how you can support 10 to 10k user, right? But initially you build with this, right, for the 100 users. So how you solve this? Now these are the scaling challenges where you had a 100 user, now you move to the 10k user. So how you try to solve that, or 10k to let's say 1 million user, right? It can go any number, right, for example, right? Now so you'll see the basically the problem, scaling problem, these are, right? Because let's say more users will start coming. So what sort of challenges? One thing is CPU load will go up, memory will start shooting, right? At the same time you'll see your server, right, becomes a SOF, single point of failure. So basically, let's say if your server goes down, because this is a one server only, then your website completely goes down. So that is the another challenge you have. So you see, once from 100 to 10k user or 10k to 1 million user, so you'll start seeing the problems related to the CPU, memory of the machine, and then server becomes a single point of failure. Because let's say your CPU start getting throttled, or your memory started spiking, right, or it reaches the limit, right, then you'll start seeing a degradation in your instance, right? So that becomes a single point of failure. Let's say if your server stop responding, okay, it goes down or crashes. So that becomes your single point of failure, right? So that's where that these odd challenges, right, will bring us to the scaling concept fully, right? Because what you do once you start 10 to 10k 100 to 10k user, right, what you do in that case, right, you have to look for the scaling the your server or capacity, server capacity, I would say, right? So that's where comes your vertical and I would say vertical and horizontal scaling. So basically you started your startup, just repeating the journey. Starting a startup, you had a one server architecture, single server architecture, and then your users increased because of some marketing campaign that you ran, or maybe some influencer marketing that you ran, 10k or 1 million user. Then you started seeing CPU memory or server becomes a single point of failure, CPU memory spikes, right? So then your website performance is degrading, right, and the user experience is impacted. So what do you do next is your server. You have to scale your server, right? So that's where this becomes your scaling problem, right? Now this is, I'm just mentioning vertical and the, okay, so now comes to the vertical and horizontal scaling, right? So think about a case where, what I mean by the vertical, right? So you assume you have your server, right? So it is of, let's say, 4 GB RAM, 4 GB, or I would say, let's say 16 GB RAM. This is the memory and the 4 core, for example, just giving some random. This is a CPU, okay? This is the configuration of your server, okay? So what I mean by vertical, because your this server is not able to handle the load, right, that we are putting in, right, 100k or 10k user, whatever it is, right? So what do? You scale your server. So vertical means it's same machine. This is a single machine, right? This size is, let's say, 16x4. You increased it to the, let's say, something 32 slash or 16, for example, right? So this is sort of a vertical scaling, where same machine size you made it bigger, means you increased your CPU or RAM for that same machine. So this is a vertical scaling, okay? So vertical scaling is limited to the a particular limit, where the size of the machine, single machine, can be increased at particular configuration. Let's say you can't make a, let's say, if let's say you are using some instance, right, server instance, I meant some XYZ that has a, like, let's say maximum it can give you 512 GB of RAM, or let's say 128 core of CPU. But if you need more, then you can't handle that with the vertical scaling also, because that vertically it has a constraint, right? Another thing is, vertically it will try to solve to some extent where you can increase the size of that same box, right, or a machine. But if you want to go further, then you have to choose a different scaling mechanism, okay, that I'll come to. Another, see, still you have a single point of failure. The scaling, vertical scaling didn't solve for you, right, if you have a single machine only, because you increase the same machine size. Still, if that machine becomes hot, you have the single point of failure. So now coming to the horizontal scaling, okay? So horizontal scaling, if I talk about, right, so let's say you have a 4 core or 16 GB machine. This is server A. Now what you do is you need to scale, right, because this was supporting 100 user, for example. Now you need a machine which can support a 1000 users, for example, okay, or a 10,000 users. So what you do is, basically, because you have a constraint or your vertical scaling, right? So how you can support this with the horizontal scaling? So same machine, this is a machine A. So what I do is A dash or A double dash. So two machine I'll create, let's say 4 core or 16 GB only, right? Same 4 core and 16 GB. So I have a 2 server A dash, A double dash. So both are serving the traffic for the request. So it means what will be the flow now is the user you have. Now what you have a server A and server B. Okay, so this is a 1 or A dash or A double dash I would say. Okay, and then database. This is the flow now post horizontal scaling. But how user knows which request to be forwarded to which server, right? Basically how user know which or how user know the request will be forwarded to server A dash or A double dash. So for that there's a concept of which comes of a load balancing, right? So now the load balancing concept is, what it does is, so basically you have the users. Okay, now you should know like which request to be forwarded where, right? So this is the load balancer, and then it forwards it to the either server A dash or server A double dash, and then it gets forwarded to the database. This is the flow. So this becomes a final flow. So why we need a load balancer? When you have a horizontal scaling, so you have a multiple servers. So how you will basically route the traffic to the correct server, right? So you should know, like you should have some strategy to route, and you should have some component which will route it, right? So that's where load balancer plays a critical role, right? So basically now with the basically coming back to the like we did a horizontal scaling, right? So just coming, this is the load balancer which will route to the server A, server B, server A dash and A dash, A double dash. So before coming to that, right, more going into the load balancing, just I want to recap on the horizontal scaling, like what benefit we got. So with the horizontal scaling, right, you got the better performance. Why? Because now traffic is divided across both multiple servers. Better reliability, because it becomes now you don't have one server, you have more than one server, right? And better fault tolerance. Okay, but now the challenge, as I mentioned, right, we use a load balancer, right, to route the traffic to the correct server, right? So there we are using the load balancer, right? That's where we were in. So now the strategy for the load balancing, right? So let's say request comes to the load balancer. Now load balancer routes, let's say 50% traffic. So it is like if whatever traffic comes, 50% goes to the server A dash and A double dash at any point of given time, right? It's sort of a round robin way, right? So that way you see the load is distributed among two servers. So this way you will have the, basically this improves the performance, that is for sure. But at the same time, it also improves the availability of the system. Right. Now assume basically this improves the availability, right? Why it improves the availability? You hope you understood. If server A dash crashes or it becomes hot, still you have a server A double dash which can serve the traffic. Still user won't be able to see if any server is down, and user will see the smooth experience, because server A double dash should be able to handle those requests, right? So that's where A double dash is coming in picture, where you see the benefit of the horizontal scaling also, right? Now another thing is when you add a multiple database, you have multiple when you add a multiple server, you have the basically single database, but you have multiple servers. Single database is connected by the multiple server. Now what happens, what bottleneck appears is, we try to solve from the forward, right? User, we have server, single server to now we have multiple server. Load balancer is like sort of orchestrator, which is orchestrating the traffic between server A and server A double dash and A dash, based on the, either it can be on the, I would say there can be multiple I would say criteria. It can be round robin or it can be anything, right? Based on the traffic pattern that you have, you decide it, right? I'm not going deep into that right now. Now, server problem, we try to solve it. Now we have a database. How we try to solve the database problem, where I'm saying ki both the server requests are going to the database. So how database can become a bottleneck here? So let's say you add a 110k users. So now let's say 1 million users becomes 10k to 1 million. You have a 1 million users. Load gets distributed amongst the server, but we are like 1 million queries going to the database. So it can be like, let's say I'm asking for a Harry Potter search word, right? So Harry Potter, so what it does is this goes in the request. So the search text, you see Harry Potter, right? Now this goes in the request. Now server A queries the database and returns it. So now with a 1 million user or more than 10k user, 10k to 1 million I reached, so database has started showing you the performance degradation. Why it shows? Because you are querying a 1 million, right? 1 million, every request is going to the database, even though that can return a same result, right? Still you are querying. So database can become a bottleneck here, right? So to try that, to solve that bottleneck, what we do is we do caching. For that we have a caching. Okay. So caching is like to avoid that bottleneck, in short, right? Where like same result I'm querying multiple times to the database, that is unnecessary, right? So for those sort of cases we use a caching, right? Which can reduce a load on the database, right? That is the whole purpose. So what you do is the caching is basically, let's say your search text has the Harry Potter, right? So search Harry Potter search text, right? Search text is the Harry Potter, or I would say, right? So there can be, if it is a, let's say, e-commerce website, there can be a multiple sellers, it can come, right? Like let's say 10 sellers with this text, right? So seller S1, S2, S3, this we queried from the where this database has written this result, right? Now what we do is corresponding to this cache key, this is a key, we store this result, this is a S1, S2, S3 in the cache, so that when the same request come again, first we look at a cache and then we checks basically if it is not in the cache, then we look at a database. So now the flow will change a bit. So now you have a load balancer. Okay. Now you have a server. Okay. So it can be any server, I would say. Server A dash, server A double dash. Okay. But it checks this box. I'm saying ki this any, like whichever server gets a request will look at a caching layer, right? Checks corresponding to that cache key, right? Like this is a get product call, and search text is the Harry Potter. So it looks in the cache. If it is not there, then it looks at a database. So that database is a sort of fallback. So first it reads from the cache. If it is a cache miss, then it goes over the database to fetch the result first and the cache it also, and then return to the client or a user sees the result, right? So that's the whole purpose of cache. Cache can be Redis or Memcache. There are multiple caches we have. So yeah, we can use either of one cache. So but you understood the purpose of the cache, right? So that's where we are using it. So if you see from the starting, we started with a single server architecture. Then we see the problem when the more users started coming. Then we see the problem of a server is becoming bottleneck. So then we have to look for the scaling mechanism. Scaling mechanism is like you have horizontal and vertical scaling. But we see once we have the more than one server, how we know which request to be routed where, right? For that, we came to the concept on the load balancing. So load balancing, once we look at, right, so load balancing we configure, right, how to route the traffic, right, so that routes the traffic across the multiple servers, that improves the availability of your website, or right, then it goes further, right. So you see, it improves the availability of the your website, means improves the availability of the server, either one of the server, right, can respond if anyone is down, right. But now, like another components come that can become bottleneck, which is a database. Now in the database we see if the same queries we are returning again and again, same response, can we handle it in a better way? That component can be a cache. If we introduce a cache in our whole cache component, right, so that can cache the response which we are querying frequently from the database, so to avoid the load on the database, right. So that's the whole purpose. So this reduces the load on the database. At the end, this is how basically these are the some of the component, I would say, that help you start scaling your website, or like a startup, right, startup website, I would say, so that you are building, right. So these is sort of a how you start introducing more new components, and I would say more new components as you see the challenges that you face in the journey, right. So yeah, so this is a way of thinking that I wanna just project in this video, so that way you understand, like whenever we try to design a system, we should know what we are designing for, right. I meant is it a, like what sort of a requirement it has, like functional, non-functional, those I'll discuss in the upcoming video. But this is how the decisions will evolve, right, from starting from a, let's say, 100k user, right, user application, right, 100 which is supporting 100 user, right. So that might not need a big thing, many components, like a load balance, like a data, like basically horizontally scaling or a caching layer. Those are not required, might not required, right. But once you go further, then you need to introduce these components to scale you efficiently, right. So that's where like my point was to show you how you should think about this, right. This is how we start thinking in the direction. Now basically you see, we transformed a simple application, right, into the scalable system, right, that is capable of handling the earlier it was 100 users, that can be capable of 10k or 1 million, that depends basically, right. Now in the upcoming video, what I am gonna cover is basically show you the, even you have the caching layer, how database still can become a bottleneck, and how you learn more about database replication, or how you handle the large scale system, like how you handle the, basically I would say, millions of requests in the large scale systems, right. Like it can be read request, like millions of read requests coming per day, right. So millions of read requests per second also, right. And so that way you'll understand more new concepts. So these are like basically the foundational video, I would say, which is like setting the tone, so you will aware about the basic concept of a system design. And I would say, I think we'll end this video here only. And I would say, like, for the stay in touch, or I would say subscribe to my channel, and like, comment and share, so that upcoming videos you are aware, like we'll introduce more new concept, just working on the core concept, and before jumping into the any of the design problem, right. So that way you, when you will go for a design problem, you know what all things, core concept that you are aware of, how you can apply it. So that will help you in designing the system in short, right. Yeah, I would say thank you all. Yeah, bye.